So today's topic is compaction. New chapter, new topic, uh, compaction. Okay. Acha. The actual definition of the compaction is a process by which the soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity or void ratio of the soil and thus increase its dry density. So compaction is a process by which the soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity or void ratio of the soil and thus increase its dry density. So the objective of the compaction is decrease the porosity or void ratio of the soil and increase its dry density. Okay, and this compaction is totally manual process. It's a totally manual process or mechanical process. Okay, normally compaction and consolidation both are same. Compaction and consolidation both are same. Compaction is the man-made process, mechanical process, manual process, but actually compaction is manually done, but the consolidation is the completely natural process. Due to building weight, due to any heavy weight on the soil surface or on soil, the consolidation process is happen. So consolidation happens on the soil for the soil due to loading, or it's a natural process consolidation. But compaction is a fully man-made process, and the purpose of the compaction and consolidation both cases are same. Actually consolidation, we cannot do consolidate any soil can be consolidated by naturally. Okay, but compaction we can do only compact. We can do compact the soil before construction. We can do compact our soil of our construction site. In our construction site, we can compact our soil. Basically, compaction process is involved in everywhere for construction site, and the most use of the compaction is normally carried out in road construction. uh, I think you all of you have seen such type of activity during road construction. Such kind of roller you have seen. Suppose in anywhere, I think road construction, during road construction you have seen this type of rollers. Okay, the name of this roller is flat wheeled roller or smooth wheeled roller. Okay, this kind of roller we are normally we are called the smooth wheeled roller or flat wheeled roller. The purpose of this roller is compacting our soil. For compaction purpose, these type of roller are used. Okay, this is called compaction. But this is the actually mechanical compaction. Manually, this process is carried out by manually. The difference between compaction and consolidation is the important. And normally what is compaction? Actually the details of compaction, the details of compaction process, only this rolling is sufficient. Only rolling on the soil or rolling through the soil is sufficient for compaction? This is the question. Actual compaction process or the method of compaction is important. Okay, method of compaction is important. So now we will go through these methods, we go through these things. What is actual compaction, the process of compaction, what are the parameters are involved in compaction. Okay, before go into the compaction chapter, so first, which is very important question for any exam, that is what is the difference between compaction and consolidation. Okay, first, compaction is the mechanical process by which unit weight of soil increased, unit weight or density of the soil is increased at a particular water content. So at a particular water content only the unit weight or density of the soil can be increased. Okay, particular water content. So only without water content you cannot increase the unit weight or density of the soil. So some amount of water content is needed to increase the density or unit weight of the soil. So compaction is that mechanical process by which unit weight of soil increased at a particular water content. And at the same time, consolidation is the natural process under sustained load due to which volume of soil decreases gradually. Both the same thing actually. This is mechanical process, man-made process, and this consolidation is the natural process. Okay, it happens due to sustained load or some heavy load, building load, maybe accumulated materials load, volume decreasing volume of soil by some material. This is can be happened naturally. So any natural process by which the volume of soil is decreased is called consolidation. And you can see in the first point that is gradual process, it is gradually. Okay, but in the compaction normally we are followed the compaction process. Normally it is a very fast process. You can see in the other points. The number 2, compaction is the expulsion of pore water, expulsion of pore air. So this is the process where the air which is present in the soil mass, in the void of the soil mass, that's that kind of air or expulsion. Normally expulsion of air is normally happen in compaction process, but in consolidation occurs due to expel of pore water. Okay, so this is expulsion of pore air, this is expulsion of pore water. The difference between compaction and consolidation. Number 3, always partially saturated soil, always fully saturated soil. So for consolidation process you need the fully saturated soil, or it is possible for fully saturated soil. Expulsion of water or pore water from the soil only possible for fully saturated soil. And for compaction normally what we do, normally we do the process where soil can be saturated partially by sprinkling water on that. So it is always partially saturated soil, that's why only air can expel out. Okay, because Expulsion of air very fast process. It is not a problem. You put apply load on the soil easily. Air which the poured air can expel out from the soil. But if you need to expel out the water from the soil, then it is a long process and some fully saturated condition should be there. Then it is possible to expel out the poured water from the soil mass. Number 4, it is an instantaneous instantaneous process, okay, or rapid process. Compaction is the rapid process, but consolidation is the time taking process. So long time is needed to perform this consolidation or this consolidation process, long time or time taking process. But the compaction is a very rapid process, fast process, instantaneous process. Mechanical equipment are used like rammers and rollers. Just you have seen the roller. Normally we are used in road construction. Also you have seen construction in any building or any the uh, floor of the building. Some rammers also used for compaction purpose. Before constructing the the room floor, normally in our building construction we are used basically for ground floor. Normally ground residential building, not for your flat kind of building. Normally we use the ground floor as a parking, but somehow for ground floor we are used the rammers for compaction, and for road we are use rollers for compaction. And consolidation is the natural process that occurs over long period of time. Okay, compaction leads to increase in shear strength of soil, stability and bearing capacity. So by compaction or with this compaction process, we can increase the shear strength of soil, stability and bearing capacity of the soil. But due to consolidation, no such benefits actually, because it is a natural process. Uh, as it is natural process, so it is not. It is actual phenomena. Consolidation is the phenomena. Okay, it is also phenomena, but we can control this. We can control compaction. We can control compaction only for engineers, only for technical persons which are directly involved to our construction. We can carry this compaction process, but consolidation is carried by nature. Okay, this is a completely natural process, but we can measure the consolidation, we can measure the rate of consolidation. Just you have studied last chapter, consolidation chapter, all the parameters which are involved in consolidation. In consolidation process we can measure each and every parameter. We can calculate the settlement, we can calculate the rate of consolidation, degree of consolidation, coefficient of consolidation, coefficient of compressibility, consolidation index. All those things we can measure consolidation, but the process is natural. But compaction process is completely carried out by ourselves. Okay, this compaction process. So in compaction process can be done by ourselves, and we can compact at a certain level, because during consolidation the from the soil, air as well as water can be expelled out from the soil in consolidation process. But in compaction process only air can be expelled out from the soil, and for that case when on because as we know, our voids in soil mass occupied by air and water. Okay, expulsion of poured air or air is easy, very easy. You apply load and easily the air can be expelled out from the soil, but the expulsion of poured water is not a easy process. So this is the difference between compaction and consolidation. uh, for compaction of any particular soil in the field, the engineer can vary water content, amount of compaction, and type of compaction. Hmm. That's why in 1933, Proctor, one of the inventor or researcher, Proctor showed that there exists a definite relationship between the soil water content and degree of dry density to which a soil might be compacted, and therefore a specific amount of compaction energy applied on the soil, there was a water content termed as optimum water content at which a particular soil attained maximum density. So if we put some compaction energy, or if we apply some compaction energy to the soil, okay, and suppose some specific amount of compaction energy applied on the soil, so there should be a water content, which termed as optimum water content. At this optimum water content, soil will gain a maximum dry density. Okay, maximum dry density. The compaction characteristics are first determined in the laboratory by various compaction tests. These tests are based on any one of the method. Suppose normally first, uh, at the beginning stage, we are followed the standard Proctor test. Okay, standard Proctor test normally, which is followed by us in the laboratory. This is a very initial test, or you can say standard test, for determine the dry density as well as the water content at which the soil can gain the maximum dry density. Okay, the purpose of the test is to find out at which amount of water content soil will give its maximum dry density. Because if you completely the soil, then soil will not give you the maximum density, or maximum dry density, but there is some amount of water which if you add with the soil, then easily soil will give you the maximum density. And the objective of this compaction test or standard Proctor test, okay, there are lots of tests, but first test is standard Proctor test, normally we are followed for compaction, and through this test we can get the value at which water content the soil will give the maximum density or maximum dry density. Okay, so now if you see in your VNS Murthy book, okay, VNS Murthy book, which is available to you, just wait. uh, Chapter 21, soil improvement chapter. Okay, soil, actually compaction is used to improve our soil. Normally to improve our soil, we are followed this compaction process. So in compaction process, in Venus Murthy book, page number 951, you can note it down. So under this chapter, there is mechanical compaction. Okay, mechanical compaction, and this laboratory test on compaction. The name of the test is standard Proctor compaction test or standard Proctor test. I think I will perform or for you in the in any Tuesday. On any Tuesday I will perform this test for laboratory laboratory class, lab class. So standard Proctor test, or simply we can say SPT test. Okay, so Proctor, one of the researcher, 1933 developed this test in connection with the construction of earthfill dams in California. The standard size of the apparatus used for the test is given. You will see the figure and table, which gives the standard specification for conducting the test. ASTM is the standard, American standard. Okay, ASTM is the American standard for the time being, and in our syllabus normally we don't use this specification, but also our Indian standard is available for standard Proctor test. I will tell you later. But this value, the ASTM designation values and the IS values, both are almost nearest. So there is no difference between the test procedure and all the dimensions of the equipments. All the same things are same, and also results are almost same if you perform through ASTM designation or if you perform through IS designations. So in both, the dimensions of the equipments are different. Okay, method is same, dimensions are different, but results also almost same. Almost if you carried out your test through ASTM designation, also you will get the almost same result. If you followed the IS method, also you will get the same result. Also the important thing is, three alternative procedures are provided based on soil material used for the test. Acha. Test procedure. I should read, just listen. A soil at a selected water content is placed in layers into a mold. Mold spelling is MOULD. Mold of given dimensions. The dimension you will see in the table. With each layer compacted by 25 blows. Normally we are follow 25 blows of 5.5 pound or simply 2.5 kg. Normally we are followed 25 blows. A soil is selected, water content is placed in layers into a mold of given dimensions. The dimension will be seen. With each layer compacted by 25 blows of 2.5 kg hammer dropped from a height of 305 mm 30.5 centimeter, subjecting the soil to a total compactive effort of about 600 kN meter per meter cube. The compacting effort of about 600 kN meter per meter cube. The resulting dry unit weight is determined. The procedure is repeated for a sufficient number of water contents to establish a relationship between the dry unit weight and the water content of the soil. These data, when plotted, represent a curvilinear relationship known as the compaction curve or moisture density curve. The values of water content and standard maximum dry unit weight are determined from the compaction curve as shown in figure. Now see the specification for standard proctor test. But before this specification, you need to see the schematic diagram of the mold. This is the mold, same as like your proctor your penetration test, which test you have done in first class soil lab. Okay, so same cylindrical mold is used for the test. This is the actually metal mold. This is the color. Okay, detachable base plate. The dimension of the mold is, if the diameter is 101.6 mm, height of the mold is 11.7 centimeter. This is without collar. With collar, the height should be 17.7, and the dimension of the collar is same, 101.6 mm. This is the hammer. Okay, this is actual figure, and these are the dimension. These are the diameter of the mold. 3 specifications are given, but you can use only A for your test. Diameter of the mold 101.6 mm, height of the mold 116.43 mm, volume of mold 944 centimeter cube, weight of hammer 2.5 kg, height of drop 304.8 mm, number of layers 3, blows per layer 25, energy of compaction 600 kN meter per meter cube. Soil material, soil should be passing 4.75 mm sieve. I think you have now idea what is sieve. Okay, already you have seen the sieve analysis lab test. In sieve analysis test, the 4.75 mm sieve is used, and our soil should be passed through 4.75 mm to perform this test. Actually, if you see the test, I have one video. I am to show this video. See this test. This is our soil. First, we are adding some amount of water. Okay. Normally, soil should be dry, and we should add the 10% water content of the soil. If soil is 1 kg, 10% water. 10% water is 100 gram or 100 ml should be water for this test. We will start from 10%. This is mold. Okay, this is color. Just you have seen the schematic diagram of the collar. This is the mold, metal mold. Diameter is 106. This is the detachable base. This is grease, or you can use any lubricant. Inner side of the mold. Just I am skipping because we need the procedure today only. The details things will be described in your lab test. This is a complete setup. Okay, this is the mold plus collar and the detachable base. Now you have to put the soil into the mold. First we have added some percentage of water, and for our testing this percentage should be 10%. Normally we have taken 10%. 10% of water. If our soil is 1 kg, the soil should be 10%. If your soil is 1 kg, the water should be 10%, 100 gram or 100 ml. Okay, first we should add optimum moisture will come after some time. This is the actual process, just follow. This is the first layer. 3 layer. With 3 layer we should follow the we should fill up this mold. This is the first layer, and 25 each layer should be given the 25 number of blows. This is the first layer and 25 blows. Second layer, then 25 blows, and by third layer we should fill up the this mold. We should fill up completely this mold. 25, 25, 25. Total 75 blows are needed to compact this or to fill up this mold. The second layer. This is the second layer. Again 25 number of blows. All of you know why he is doing like that. This is for bonding. Bonding between to get better bonding between two layers. That's why he is doing like that. Also same things we are followed in our column casting. Okay, when concrete is used for column casting, same thing we are done. This is the third layer, and again 25 number of blows. Normally this collar is provided because to protect our mold. Okay, to protect our mold. The actual purpose of the collar is to protect our mold. 5 mm extra. He has taken 5 mm extra. After completing the these 25 3 layers, we don't need this collar. Now this is our mold, or this is our sample for testing. Test is just only we have to find out the volume of the soil and weight of the soil. Okay, volume of the soil and weight of the soil to find out the density. Suppose, just for example, if we added 10% water, okay, after 10%, after adding the 10% of water, now the after filling up this mold with 3 layers, and 20, each layer should be 25. What should be the unit weight? What should be the what should be the density of this soil? That is needed to us. Okay, that's the things we needed. After filling the mold with 3 layers, suppose first you have added 10% water. Suppose 1 kg soil, 10% water. Now fill up the mold with 3 layers. Each layer should be 25 blows, and find out the density. Okay, he has taken weight. Already he has the volume of the mold, volume of the soil. So easily can we find out the density of the soil. And again we have to take some sample for determine the water content. As we know, 10% water we have added, but again we have to test the what should be the water content. That's why if I pause this video, you can see first volume of the mold he has taken 1000, weight of mold he has taken, weight of mold plus compacted soil he has taken, weight of compacted soil, this is actually our need, weight of compacted soil. So bulk density, he has been determined the bulk density of the soil. Now water content. Water content will come after 1 day. Okay. Suppose if he has taken 10%, but somehow after testing 1 day, or after getting the result after 1 day getting the result, the water content may be 8%. If he has taken 10%, maybe it may be 8% after 1 day. So after test, again you have to take water content. You are adding water, you know the value of water, you know the percentage of water, but again after testing you should take the water content value. You should calculate, you should determine the water content. Okay, and finally he is calculating the dry density. Okay, this is the first trial. Normally we are carried out 3 to 4 trials for this test. Okay, suppose first time you have added 10% water, second time you should increase the water content 10 to, suppose you have added extra 4%. So first time if you added 10%, second time your water should be 14%, third time your water should be 18%, fourth time your water content should be 22%. So all the time you are increasing 4%, 4%, 4%. Okay, and by adding this percentage, extra percentage, you are all the time you are getting some bulk density of your sample, bulk density of your soil. So now bulk density is available for all the cases. Also actual water content of the soil is available to you. So when bulk density and water content is available to you, you can find out at which water content your soil is giving the maximum density. Okay, so this is the actual objective of this test. Okay, so finally we can see in our, this is the dry density of the sample. Okay, gamma d equals to gamma b by 1 plus w. This is the formula. So this is the density. And
water content by
yeah.
water content by
Wait. The same process he will follow for 3 times or 4 times. This is the actual table. This is actual table. 4 times he has followed the test, and he has the 4 results he has. Suppose first time he has taken water content 10, second time suppose 12, third time 14, fourth time 16. Suppose I don't know what amount of water content he has added, but he got first the actual water content 8%, first time 8%, second time 9.1%, third time 10.8%, fourth time 12.6%. Okay, and corresponding this water content, he got some bulk density of his soil. First time 1.92 gram per centimeter cube, 2.04 gram per centimeter cube or gram per cc, 2.15 gram per cc, 2.13 gram per cc. These are the 4 values of bulk density which he has got from these water contents. Okay, for this water content he got these bulk densities. Now he has the bulk density, number of bulk density and number of water contents. But for our test, bulk density is not sufficient. We have required the dry density. If I have the water content value and bulk density easily, by the formula, using this formula gamma b by 1 plus w, I can find out the dry density. Now the water content is available, dry density is available. When the water content and dry density is available to me, okay, so then I can draw a graph. I can draw a graph. Which graph? This graph. I can draw this graph. I can draw this graph. Okay. You can see in this graph in this graph, x-axis presents the moisture content, okay, or water content, same thing, moisture content or water content. X-axis is moisture content, which is your this thing, already you have seen water content or moisture content, and y-axis is dry unit weight, which can be calculated if I have the bulk unit weight. Okay, if I have the bulk unit weight and the water content, I can find out the dry unit weight. So x-axis represents the moisture content or water content, y-axis represents the dry unit weight. Now draw the curve. Suppose this is actually this curve. These are for another test, or these curves are for another test. You can see this curve. Okay, my cursor is going through the curve. So this is for standard Proctor test curve. The name of the test is standard Proctor test. Suppose your result is 12. Sorry, your water content is, when your water content is 12 and your dry unit is suppose 1.7, you are here, your coordinate is here. When your unit weight is suppose 16, sorry, your water content is suppose 16 and your dry unit weight suppose 1.84, you are here, your coordinator here. So what we can see, first water content 12, then water content 16. So at water content 12 the density is only 1.7, at water content 16 the density is 1.84, which is clearly can be seen from the graph. Okay, this is one of the example graph. So therefore water content is increasing, unit weight is increasing. Let's see the next value. Suppose water content 20 and dry unit weight from the graph is 1.72. Okay, what happened? First 12, water content is 12, 1.7. Okay, water content increases, water content 16, unit weight, dry unit weight is 1.84. Okay, water content increase, unit weight increase. Then water content 20, but unit weight is 1.72. Why? Because this is the actual water content that which is need for me. Actually this is the maximum water content at where the soil is giving its maximum dry unit weight or dry density. This is the nature of the soil. When you will add certain percentage of water with soil, you will get the maximum dry density. Okay, but if you add maximum water, you will get less density. Also same time, if you add less water, you will get the less density. But certain percentage of water is there. By adding with soil, you may get the maximum dry density, and for the construction purpose we need this water content value. Okay, by find out this water content value we can increase the density of soil. By increasing the density of soil only we can construct heavy structure, heavy dam or road, whatever, we can increase load on the soil. That's why this test is first test, or this test is the basic test or very vital test for soil mechanics. Also in laboratory, soil mechanics laboratory, when any client will come for testing, he will give you the undisturbed sample to you, and first you have to follow this test, this standard Proctor test. This is very important test for our soil mechanics, or as a civil engineer for soil report, to making soil report, this test is very vital test, very important test. I think today is sufficient. I am taking attendance. Wait, don't leave. Thank you. You can leave.